First three units are very important, probably the most important in EDC. I have attached few more important points in video's description, which should be known to you. In the description of each video, the short notes for corresponding as well as the previous units are attached. I might have used the words diode and PN junction interchangeably, but they are not exactly the same. Diode is a unilateral device which ideally allows current in one direction and rejects the current flow in the reverse direction. But diodes can further be of different types, like metal semiconductor junction and PN junction. You have studied PN junction, which is a type of diode, but not exactly a diode. We will study few more types of diodes which may not be important for GATE, but questions can be asked in other competitive exams. Out of a variety of diodes, we will see a glimpse of only three diodes: tunnel diode, breakdown diode, and Bragter diode. There are many other types of diode as well, like gun diode, imped diode, but we will not focus on them. Actually, what we are studying here is a very small portion of EDC application. You might already know majority of devices operate on AC, but whatever I have covered here, I have always considered DC analysis only. You can actually divide component analysis into three categories: DC analysis or the low frequency analysis, intermediate frequency analysis, and high frequency analysis. To understand the difference, let us consider a very simple circuit consisting of a capacitor and inductor. It should be known to you that impedance of inductor is given as j omega L, where omega is the angular frequency and L is the inductance. Similarly, capacitor impedance is equal to 1 upon j omega c. If we consider DC analysis or low frequency analysis, then for DC analysis, frequency corresponding to DC is taken to be 0. And for our ease, at low frequency analysis, we also take frequency equal to 0. Therefore, inductor impedance at low frequency will be approximately equal to 0, whereas capacitor impedance will be very high, leading to infinity. So, if we convert this circuit for low frequency analysis, then it will convert into this circuit. Similarly, for higher frequency analysis, we will have capacitor impedance to be equal to 0, whereas inductor impedance leading to infinity, and the resultant circuit will come out like this. But when we deal with intermediate frequency, where we cannot ignore neither the inductor nor the capacitor, then the original circuit will have to be considered for analysis. The similar analysis can be done for equivalent model of different components. You have studied diode equivalent model and will study BJT and MOSFET equivalent models also. For competitive exams in EDC, we mostly deal with DC analysis. We don't even consider low frequency circuit. Gun diode, imped diode are the diodes which have applications on high frequency, and they have a special property of negative resistance. For graduate level competitive exams, only DC analysis is taken into consideration, at least in EDC. In analog electronics, however, you will have to deal with low and high frequency circuit models of BJT and MOSFET. First, we will cover tunnel diode, Bragter diode, whose applications can be well understood by considering DC analysis only. Let me make it clear that the application of tunnel diode is also at AC. However, its mechanism can be well understood by considering the DC voltage only. Diodes like tunnel diode, gun diode, and imped diode have property of negative dynamic resistance, and dynamic simply refers that its application is based on AC current. After covering these special diodes, we will look into some latest gate questions. And finally, we will move to our next unit, which is BJT. However, the concepts of BJT are not linked to MOSFET. So, if someone wants to study MOSFET before BJT, then it will not be having any problem. The study of MOSFET and BJT is very limited in this subject. Many good questions are usually framed from analog electronics. It is your job to keep good understanding of BJT and MOSFET so that it is easy for you to link topics of analog electronics 2. Electronic devices and circuits.